Hello, I am Triptayan Chatterjee from 7th Quantum Academy with another wonder world that is called dimension. Dimension. I think that it sounds like a familiar word you have used when you studied physics. Dimensions have n-dimensional meaning, but we are referring to that dimension which most of which dimensions are not observable at all. In case of dimensions, what do we think? That it is practically a mathematical tool to find out something, exactly the place and functions of a particle or something like that, or any kind of quantity, any kind of vector or scalar. But actually the dimension is something different that we imagine so far. In our eyes, dimensions are basically 1, 2 and 3 dimensions. When you talk about one dimension, we generally give only a straight line and give the name that x, only x, that is the one dimension. When we go for the two-dimensional world, we give the name x and y, two axes. It is called Cartesian coordinate. And when we go for the three-dimensional, that is Euclidean geometry, that is stated as x, y and z. So to find out the location or of a particular functional point, we would describe this three-dimensional place with x, y, z, that 1, 2, 3. That 1 is along x, 2 is along y and 3 is along z. And this will be the point where we were looking for. This is the dimension familiar to us. Whatever we are looking, whatever we are observing, whatever we are feeling with our 5 traditional sense organs, and sometimes with high-end devices in space such as Hubble Space Telescope or something like that, very high-end precision devices, we can find out the three-dimensional beings there. But in that case, it was a common phenomenon to find out something at three-dimensional places, and then these three-dimensional places started to explain everything we observed in physics. In 20th century, at the threshold of the 20th century, Minkowski space was discovered. That was the fourth dimension, and arrow of time was added at the fourth dimension. So, if we think that three dimensions as only a single line and fourth dimension is another axis on it, then it is the fourth dimension, and time has been considered as the fourth dimension in Minkowski space, which was then later implemented by Albert Einstein to explain the space-time curvature. So up to threshold of 20th century, it was narrated that there is only 4 dimensions here. Whatever we are observing, finding, those are in 3 dimensions with another extra dimensions, that is time. Because as we are observing time in passing, and time is always going forward, which is called arrow of time. Whether there is a contraction of time or time dilation, that is something different, which will be explained later in different sources. Now the case is, when science started to go for another further research, it was observed that many phenomena, along with many kind of factors which are not being explained by this fourth dimensional concept only. Particularly the Kaluza and Klein started to say that there is another dimension. If we add there, the problems are easily solved. What kind of problems are there, we will discuss in our another video, when we will be going to narrate you dimension wise, that we will have the videos separately for first dimension, second dimension, third dimension, fourth dimension, up to 11 dimensions as it has been described in the string theory. But when string theory came into existence, it got clear that there are actually 11 dimensions. 11 dimensions are there, but we cannot observe all the dimensions. Particularly, we cannot feel, we cannot observe beyond 4 dimensions. These dimensions have some specialty. If we think about the 5th dimension, This dimension and fourth dimension, there is a small boundary between them which is very much compactified. This boundary is called D brain. D brain. Why brain? Brain comes from membrane. It is so much thin that its thickness is only about a Planck's length. It is compactified on the fourth dimension. So this fifth dimension level is called the D brain. Then between fifth and sixth there is another membrane which is explained about Calabi-Yau space. Calabi-Yau space. That is a complex geometry which explains how the other dimensions are given according to so far research I am telling you. So this Calabi-Yau space and Kaluza plane space is going to explain the fifth dimension, sixth, seventh, eighth, ninth and 10th dimensions. What are the dimensions? Every dimension has some properties. First one, it has a scalar field and gauge field, Fermion field, etc. etc. What about this field? Actually, these dimensions boundaries are marked with Dirichlet boundary conditions. It is one of the very important event, and it has a special mathematical representation we will discuss later. This Dirichlet boundary condition is such a place where an open strings go and touches with its both ends there, and all the activities with the brain at that particle which took part in the lower dimensions starts to interact. So the interaction between the particle and brain takes place at the Dirichlet boundary condition. Not only that, one dimension and another dimension starts to interact with each other in the Dirichlet boundary. Except this Dirichlet boundary, there is another feature which is called the world sheet. World sheet means these boundaries are also expanding. In our three-dimensional world, it has been said that our universe which is observable is expanding more than the speed of light according to Hubble's theory and Hubble's constant. But the dimensions are also expanding. This is also the expansion, so this expansion from one place to another and getting a shape as the boundary. There is one term that is called world sheet. World sheet is formed with the tension, with the trace, with the stress and with other factors that is creating on that dimension, particularly stress and tension, and this is making the scalar field of the boundary, with which field we can find out a particular place and its properties. Except scalar fields on a specific dimension, there is gauge field, there is Fermion field. These gauge fields give the birth of the different particles there. You can say that particles wave are same and it depends upon the observer's effect. So particle wave particle duality of the quantum physics is a basic property here. So whatever the phenomena we are observing, we cannot explain with our traditional mathematics, cannot observe with our traditional sense organs or with our traditional high-end machines and devices, are basically not in our dimension. To represent geometrically and graphically and mathematically, if we add other dimensions, we see the physics of the other dimensions something different from the dimensions we are living in, we are habituated in. The universe which we are watching here is actually the three-dimensional universe. But from the 5th to 11th dimensions, there are different kind of properties, different kind of scalar fields, different kind of gauge fields and Fermion fields. And sometimes these fields are taking part in a particular dimension which is not available in its lower dimension, it is available in the other dimensions. On the upper dimensions, the more we go, we get more and more newer features that gives the birth of the different kind of events which is not familiar in our third dimensional world. So this dimension is a very important factor in string theory. The different events which are taking place and being reflected in our dimensions and cannot be observed with a complex number, with a complex plane, with other kind of mathematical tools, we had to make different kind of differential geometry, different kind of mathematics to explain that where the another dimensions is added and the problems is solved easily. So the existence of dimensions in the different places, it is known. And this dimension, if we consider the first dimension as a point, then the 11th dimension is a straight line, as it has been said in the string theory. But all other dimensions are different shapes. From these shapes are basically described by the Cartesian coordinate, the Euclidean geometry, Kaluza-Klein geometry and Calabi-Yau space geometry. So this is the dimensions. But what actually the dimension is, how is the dimension, how is the separate dimension, how is the particular dimension, what is the feature of this dimension, how do this work, how can we go to this dimension to feel and observe the events and happenings taking place there are to be described in our next videos one by one. In this dimension playlist, just follow us to get the knowledge and delve into the wonder of these dimensions in each video, where every video will describe every dimension separately. To know more, just subscribe our channel 7th Quantum Academy and just tap on the bell icon to get notified when new videos are uploaded. Till then, goodbye from Triptang.